You are now on the third video for this lesson of the parent graph functions, the parent graph patterns. And so, let me teach 19 to 26, and then there's some general rules as well for the polynomials. Let's start with number 19, your positive absolute value of x. And so we can plug in a couple numbers here, a couple numbers meaning 5 of them. Usually I just plug in these. Okay, anything in the absolute value makes it positive because that's how many steps it takes from the number line. So if absolute value is 0 because it takes 0 steps. It's 0 away from 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Absolute value of negative 1 is 1 because it's 1 step away from 0. It's 1 step away from 0. Absolute value of negative 2 is 2. So this is going to be your pattern, and this is really a strict V shape. Okay, so V shape, there shouldn't be any curves at all. So start from your starting point, 1 to the right, 1 up, 2 to the right, 2 up, 1 to the left, 1 up, and 2 to the left, 2 up. Okay, so it's a strict V shape that's facing upwards. And you can probably already tell what number 20 is going to be. For number 20, for the negative absolute value, it's going to be facing down. Okay. 0, 1, 2, negative 1, negative 2, and I'm just going to give you guys the numbers already. Negative 1, negative 2, negative 1, and negative 2. Because with this negative 1 that's in front of the absolute value of x, you're going to multiply that last. So this time around, you're going to go 1 to the right and 1 down this time. 2 to the right and 2 down. 1 to the left, 1 down. 2 to the left, 2 down. So those are your patterns for your absolute value parent graphs. Let's go take a look at an example. So an example would be number 50. Number 50 could be a good example over here. So number 50, let's state your starting point again so that we know where to start at. So again, this negative up front does not affect the starting point. So we're going to look at these two numbers here. Remember, opposite of what you see. Negative 4, I see. Positive 4, opposite. And then after that, same as is, negative 1, same. Let's start over there. 4 comma negative 1 is here. And then what pattern you're going to follow? You're going to follow the negative absolute value of x. Okay. Negative absolute value of x was number 20. Okay. 1 to the right, 1 down, 2 to the right, 2 down, 1 to the left, 1 down, 2 to the left, 2 down. Okay, so let's just do that. So from the starting point, 4 comma negative 1, you're going to go 1 to the right, 1 down, 2 to the right, 2 down. Okay, I kind of checked off prematurely. All right, now go back to your starting point. You're going to go 1 to the left, 1 down, and 2 to the left, 2 down. Okay, so rights and then lefts. And then strict V shape, shouldn't be any curves at all. Okay, so those are your absolute value graphs. Let's move on to your rational functions. Okay, so this is, I should name them actually. So absolute values. This is rational functions. Rational is just another word for fractions. Okay, rational fraction functions, pretty much. Absolute values, rational functions, quadratics, okay, square roots, cubic functions, cube root functions. Okay, rational functions. So what is going to happen is you are going to, and actually let's kind of take a look at what's going to happen over here if we plug in 0. Okay, and I think it was already stated before on some of your previous lessons and some of your other courses as well. But if we do 1 divided by 0, we cannot divide by 0. It is undefined. So I'm going to go undefined, or maybe I'll just put error over here, so we can't do that. But we are going to plug in two other numbers. We're going to plug in 1 and -1 because we can at least get points for that. Okay, so plug in 1 in the denominator here. 1 divided by 1 will be 1. Plug in -1 over here. 1 divided by -1 will be -1. Okay, so from your starting point, wherever that is, you're going to go 1 to the right, 1 up, and then 1 to the left, 1 down. But what ends up happening is, maybe I should have grabbed a couple colors. That's okay. From our starting point, we are going to make a vertical and horizontal asymptotes. Okay, so vertical and horizontal asymptotes at the starting point. Asymptotes are just, you can think of them as boundaries, and the functions most of the time, not always, most of the time will not pass it. And so the asymptotes will give you guys shape of those functions, like where it's not supposed to be passing most of the time. Okay, so if you can take a look at the rational function, the positive 1 over x, and you can think of them as quadrants. Like this is on quadrant 1, and then this one's on quadrant 3. So you know, like the top right and then the bottom left. Because when we do number 22, -1 over x, if we were to plug these in, okay, if we do 0, it's going to be error again because we're dividing by 0. But if we plug in these numbers, the 1 and -1, if we plug in 1, -1 divided by 1 will be -1, which is this dot over here. And if we plug in -1, then this will turn into positive. Okay, so we're going to go 1 to the right, 1 down, 1 to the left, 1 up. Okay. And we're still doing vertical and horizontal asymptotes for 21 and 22. So it gives that rational, it gives the shape for the rational functions and where to go. Okay. Okay, so vertical and horizontal asymptotes for both 21 and 22. Let's go do an example, definitely. And an example for that will be, I just gotta find it a little bit, number 53. So number 53 is a good one over here. So we're going to graph this. So first off, we need to find your start point. It's going to be the same thing, opposite of what you see by the x, and then as is on the outside. So opposite of this will be -1. And then as is, or the same, -3. So -1, -3. -1, -3 is right over here. You are now going to make your vertical and horizontal asymptotes, our boundaries, okay. Let's see what pattern we're going to follow. We're going to follow the -1 over x pattern. I always have to look back. Number 22. Okay, number 22. So for that one, we have to go 1 to the right, 1 down, 1 to the left, 1 up. And let's go ahead and do that. Okay. So from the starting point, which is over here, you're going to go 1 to the right, 1 down. Go back to your starting point, 1 to the left, 1 up. And you're going to make curves on those quadrants on the top left and the bottom right. So just kind of like make it like that as close as you can, but it's not going to be touching. Okay. So same thing over here, as close as you can, intersecting at that point over here, but they're not going to be passing those asymptotes, those boundaries. So that's how you're going to be graphing stuff at number 53. Okay, well, let us do logarithms and exponents now. Exponents and logarithms. Okay. Your basic exponential function can be 10 to the x. And so let's go plug in a couple numbers. And I think I've only done 2 numbers really. Okay. plug in 0. 10 to the 0, anything to the 0 power is 1. So that's going to be your first pattern. And then the next thing I plugged in was 1. 10 to the 1 power is 10. So from your starting point, you're just going to go 1 up. Okay? So from the starting point, you're going to go 1 up. And then go back to your starting point. You're going to go 1 to the right and then 10 up. But you're going to make a horizontal asymptote at the start point. Okay. So at the start point, you're going to make a horizontal asymptote. The start point for this graph is going to be 0, 0 will be here. So again, for asymptotes, for the most part, it's not going to be passing this. And hopefully you guys can see that this function is not going to be passing this horizontal asymptote. It'll just kind of just go like that. Okay. Okay. All right. Now for your logarithms kind of just go the other way. So we are going to plug in a couple of the numbers here. And then logarithms, if you don't see a base, this is a base of 10. Okay. All right. So let's plug in a couple numbers. Actually, let's see what happens if we plug in 0. If we plug in 0, some things do happen. Logarithm of 0, let's see what that is. It's error, it's undefined, so we cannot do that. Okay, so that means that that's where our asymptote is going to be. Okay, but we can plug in a couple numbers. Logarithm of 1. Okay. I think I put too many parentheses, sorry. Okay, too many parentheses, but a log of 1 base 10 is going to be 0. And then let's do log of 10, that's going to be 1. Okay, so log of 10 is going to be 1. So from the starting point, you are just going to go 1 to the right and don't go up and down. Then from there, you're going to go 10 to the right and then 1 up. Okay. These two are inverses of each other, and so we're not going to have a horizontal asymptote. What we're going to have is a vertical asymptote at your start point. Okay. All right, with that said, let's go move on to an example with a logarithm so that we can just graph that one. So I think a good example would be 55 would be a good one over here, so 55. Okay. All right, well, I mean, hopefully by now, in this third video, that you can find your vertex or your starting point. So your starting point is going to be -1, -2. So -1, -2, right over here. And then you are going to make a vertical asymptote. So you're going to make a vertical asymptote, meaning that the function, we're going to give some shape, it's going to just only be facing to the right side. Okay? We are going to follow the log of x pattern that is described at number, I'm always flipping, always flipping, number 24. Okay? So we're just going to go 1 to the right and nothing up and down. Okay? Then we're going to go 10 to the right and then 1 up. So let's go ahead and do that. So from the starting point, and we've already made the vertical asymptote, we're just going to go 1 to the right. Bam, you're done. Okay? Then you're going to go back to the starting point, go 10 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you're going to go 1 up. Logarithms have like this kind of like R shape, sort of R shape like this. I mean, without like that little thing over here. I kind of forgot what that thing is called, but sort of R shape. It just follows that there shouldn't be anything on the other side. Okay, so that's how you can graph a logarithmic function parent graph. And then I want to do ease and natural logs. Okay, ease E is approximately 2.72. And later on, I can tell you guys like how it got derived from, you know, E is an irrational number. It's similar to pi. Pi is 3.1415. E is 2.71, 2.7. I usually round that off to 2.72. Okay. And I can show you guys a little bit later when we get into that. Okay. So here is another exponential function. And I think we have an example for that one too. Okay. So if we plug in 0, remember anything to the 0 power is going to be 1. So that's already going to be our first thing. This one I just kind of had to just approximate, you know, your E function. I'm just going to have to do the shift. E to the 1 power is 2.718. So that's why I'm just kind of like 2.72 less than 3. Okay, so this is a really approximate value over here. Okay. And very similar to your exponential functions. So your exponential functions should always be having a horizontal asymptote at the starting point. Okay, so horizontal asymptotes for numbers 23 and 25. Okay, I do believe I have an example on that one. So let's go on to numbers 54. Okay, 54. Let's take a look at your start value. Your start value, opposite, same. 1, 1. 1, 1. Okay. Then, over here, you're going to make a horizontal asymptote, left to right. So it will not pass this part here. We're going to follow the e to the x pattern. And on this worksheet, it is number 25. Zero left or right, but 1 up. 1 to the right, 2.72 up. Okay. So from the starting point, you just go 1 up. Bam. Then go back to your starting point. You're going to go 1 to the right. And you're just going to approximate 2.72 less than 3, you know, 1, 2, and then something over here. And then for your exponential functions, you're going to make a J shape, okay? So a J shape would be, okay, something like this, that's just going to be your exponential function over here. Okay. All right. I'm going to stop. Oh, we have natural log as well. Okay, let's just do natural log. So log and natural log are this is a type of log. It's a log base E. And we will review logs and natural logs too, I believe maybe 2 lessons from now, I think. Natural log of x. Okay. I think I plugged in 0, 1, and e to the 1, I believe. We could do 10 as well, but it's okay. So right now we're just really just approximating over here. Natural log of 0 will also give us an error. Let me do that one more time. Yeah. So it'll just give us an error over here. Okay. Natural log of 1 is going to give us 0. So that's a good place to start. So 1 comma 0. Natural log of e, and then to the 1 power, is going to be 1. I don't know why I put natural log of 10 because we're not even matching 2.3, I guess. Okay. Okay. So, if you want, maybe you can grab these two, but you can also do e. E is 2.72, e to the 1 power. Okay. You're still going to make a vertical asymptote. Excuse me. Ooh, and I did not make it with the vertical asymptote. So your vertical asymptotes are going to be over here. And right over here. You're going to make vertical asymptotes at the starting point. And from the vertical asymptote, you're going to go 1 to the right and 0 up and down. Now, this is just really approximates, you know, 2.72 to the right, and then 1 up, and then if you want to make a better shape, then you can go 10 to the right and 2.3 up. Really, when it comes down to it, if you take a look at your, take a look at these, your log is a little bit more like, it's a little bit more kind of flat, as opposed to your natural log, it widens up a little bit, okay? And you can also see that with the exponential functions, 10 to the x is just zoop. It's just a kind of a little bit narrow, where as opposed to e to the x, it's a little bit wide, okay? I believe I have an example on this one, so let's go take a look at this. I do not. I do not have an example on that one, so apologies for that. Okay. All right. Before we get down to, I think I want to finish up with your polynomials. There's no examples for this, but what I'm saying is that these are just general patterns. So sometimes you'll have general cubic functions, you'll have a string of numbers, but really the highest degree is 3, so that's a cubic function. Take a look at like how it is. Okay, so 1, 2, you could have a maximum of 2 turns over here. Okay, so 1, 2, the maximum 2 turns, it's 1 degree less. Okay, not always all the time, but I'm just saying that it is a maximum of 2 turns. You could also even have just have 1, depending on the equation, as opposed to your general negative cubic function. Now it is decreasing, and then it increases, and then it decreases like this, with still 2 turns, okay? This one over here, increase, decrease, increase. This here, decrease, increase, and then decrease, okay? Let's move on to this. Yeah, so there's really no quartic functions, your 4th power over here, and take a look at also how many times it passes the x-axis. At a maximum 1, 2, 3, 4. In max 4 x-intercepts, okay? You could have 3, you could have 2, you could have 1, depending on the equation, but maximum 4 x-intercepts because of that x to the 4th power. You could have less, you cannot have more. And take a look at how, for the positive one, it decreases, increase, decrease, and then increase, which means that it will have 3 turns, 1, 2, 3 at the most, okay? Same thing over here with the general negative quartic function. It's just going to be the opposite. Increase, decrease, increase, decrease. You have a maximum of 4 x-intercepts here, and you have 3 terms, 1, 2, 3 at the max, okay? Then, you know, really the pattern when you keep going higher and higher, and that's why I stopped at the 6. You know, when you have your quintic to the 5th power, 1, 2, 3, 4, 5. So 5, maximum 5 x-intercepts. It can be lower, but it cannot go higher. Okay, and then take a look at the increasing increase, decrease, increase, decrease, increase. 1, 2, 3, 4 turns. Okay, 1, 2, 3, 4 turns at the max. Okay, but really in general, it's just like a general increasing function, as opposed to your negative quintic function. This is a general decreasing function. Decrease, increase, decrease, increase, and then decrease. Okay, like that. And again, max 5 x-intercepts, but 1, 2, 3, 4 turns. Okay, I think you get the pattern now with the general sextic. And after a while, you know, the even functions will have the general pattern of the even functions, and then the odd number exponents will have a general pattern of the odd numbers. Okay. So to the 6th power, 1, 2, 3, 4, 5, 6, max 6 x-intercepts, and it's generally increasing on both decrease, increase, decrease, increase, decrease, increase, like that. And then your negative sextic functions will go the other way.